Hello everyone, welcome to my channel. Thank you for watching Ning Daily. This is week 2 of working in AstraZeneca. If you're not sure what I'm talking about working in AstraZeneca, head over to my week 1 video where I actually give an explanation of what I'm doing in this series. So basically I am starting an internship in AstraZeneca and I want to document them. But head over to watch week 1 and then keep on watching week 2. You can also see another video of me coming to Macclesfield. Today's day 6, which is the first day of the week. I didn't really do much, so just finishing up collecting my materials and then reading more SOPs. So yeah, it was a good week and the weather's really good right now. Hello, this is day 7 of working in AstraZeneca. So today I finished all my SOP reading, which was amazing, and I also had a lab training, but honestly I've been in the lab before that collecting my materials, so it was nothing much. But yeah, there's one SOP that was quite interesting. So it is on GMP, which if you don't know yet, it means for good manufacturing practice. And basically the purpose of practicing GMP in all pharmaceutical production is so that we make sure that we produce quality products, because one, patients don't really get to choose what kind of products they use because the doctors recommend them. And the other one, another reason is because patients are not able to physically check the quality of the product. They can't see it by their eyes. So it's so important for pharmaceutical companies like AstraZeneca to make sure that their products are compliant with GMP. And there are actually 2 quotes that I really like, which the first one is by Henry Ford. Quality means doing it right when no one else is looking. I think this really reflects one of AstraZeneca's values, which is we do the right thing. So it doesn't matter whether someone's looking or someone's not looking, we always do what is correct. And the next one is quality is not an act but a habit. That's by Aristotle, which is again really true. Like, we don't practice good quality just in front of people or whatever. It's a habit that we should do regardless of the time. And some of the rules of like having good qualities, be proactive, be a role model, apologize when you actually do something wrong, involve people, so engage with your employees, listen to them and share best practices instead of blaming each other. And also another very important one is I saw is understand your internal and external customer needs and strive to exceed them. So basically, customer context here does not just mean people who buy like AstraZeneca products, etc. But customer means whoever's next in your production line. So if you're producing goods, or if you're producing a for example an API, your customer will be the formulation scientist in the next stage of production. So whether it is someone from AstraZeneca or external customer, we always make sure that we pass down the best quality product to them. And poor quality is, you can cause people to lose lives, you lose billions of dollars, and it also damages the trust people have. So there's some quality systems, and that was one thing that I found out about quality, GMP practices, and I wanted to share with you, especially how it ties into AstraZeneca's values, which are really important in your interview process. So make sure to keep that in mind. And that's about it. That's it for day 7, and I'll see you tomorrow. Bye! Hello, this is day 8 of my AstraZeneca internship. So actually from yesterday onwards, I finished watching all my SOPs, which was really great. so I can start to focus on my project now. And so what I've done today is actually reading through this the articles that have been written up on the analysis method. So I've made some notes about them and why that provides a better analysis method than your conventional HPLC, and also what to take note of in designing an experiment to validate the process. I was also brought to a to the lab, so it was a lab that I've been before but not in detail, and yeah, finally I have like the actual information down of what I've seen, so I'd just like to share it with you, which I think would be really interesting. So so the first two machines that we looked at was to measure the shear strength or the shear force of powder. So basically the first one is a Schultz and the other one's a FT4 powder rheometer. So basically what they do is they measure the strength or the flow of the powder, which will affect one, either when you add, like when you transfer the powder from a container to another mixing process or whatever, that flow will be affected, that will be affected by its powder flow. And another one is if a large amount of the substance, like either the excipient or the API, is included in a formulation, and when you make tablets, when you want to fill them into capsules, the flow will also affect how well the powder flows, will also affect the filling rate. So that's why flow is so important. It's something that we measure when we create medicines. So the Schultz basically is a machine where you fill the powder into like a pot basically, and then you have something on top that closes it, and then it will just slowly rotate until it hits the breaking point. So the powder, it should be flat until it hits the point where the powder breaks apart. That is so that's the maximum limit for the powder. And then for FT4 it's similar, but instead you put the powder in a beaker, and then they have a sort of, it's a bit like a mixer kind of thing, but it's basically two arms, and you put it in down, and then it will twist again slowly until the powder breaks apart. So those are the two machines that they use for measuring shear strength. And another machine that they use is called Wankel tap density, which I think quite common. Basically you have, so when we measure the density of powders, there are two that we measure. So one is bulk density, one is tap density. Basically bulk density is when you fill in the powder straight into the volume, like straight into a container without doing anything to it. But sometimes when you tap, the air or any gaps in the powder will basically give it out space so that the powder falls down, so the volume decreases, and that's the ratio that we will measure. So that's also something that is in the British Pharmacopoeia that we have to provide information on when submitting our documents for regulations. The next one is a BET nitrogen adsorption. So that is actually to measure the surface area of particles. Now what it does is, first of all, the container, so it is a very small flask, small round bottom and very thin long neck. The flask with the sample will be super freezed in liquid nitrogen, so they actually have a small tank of liquid nitrogen there. And after that, in the machine itself, it will also, the sample also has to be dried out, vacuum dried. And after that, the machine will inject nitrogen into the sample, which is in the flask, and then see how much of, and then they can measure how much nitrogen is adsorbed onto the surface of the sample, which basically is a powder. So yeah, the nitrogen will get all around it. And I've asked why they use nitrogen instead of any other gases. Basically it is because nitrogen is, again, quite a small element. It's like 7 on the scale, and it is also an inert gas. So yeah, either, if not nitrogen, krypton might also sometimes be used, but nitrogen is what they're commonly used. And then the other another device is helium pygnometer. So this measures the true density of the powder. So earlier on we mentioned about tap density. Now this true density, basically it is it's even tighter than tap density. So tap density, you might get very little gas left in it. But with true density, is that even if regardless of the arrangements of the powder molecules, we will just measure the individual density of that single unit. So how it works is actually there's a chamber, so a very tiny chamber, and obviously the machine would have known the volume of that chamber and how much mass of helium would fill the whole chamber. So we would fill the chamber full with the sample. Obviously there would be gaps, there would be air and hole, and then we inject helium into the chamber until it's fully filled, and then depending on how much helium was injected in, we use the total mass of helium that would have filled the chamber, subtract it out, and we'll get the mass of the mass and the volume of the sample. So the volume is kind of fixed, it's the chamber's volume, but then we'll get the mass of the powder, and from there we measure out the true density. And the true density isn't really an information needed for GMP or to submit up for regulations, but it is used in other calculations or to measure the porosity of the materials in another machine. So even powder, they do measure the porosity as well. And another machine that we have is a texture analyzer. So this is to measure the tensile strength of it depends what we do. So sometimes when we roller compact some powders, so that's basically like dry granulation, and then you make it into ribbons. We want to test the crushing force or the tensile strength of the ribbon. So that's when they test it. It's similar. It's like a force machine going down until it breaks. Yeah, and sometimes this is quite important because we want to check and see. So some materials can be really hard, or if they are like agglomerates, so they kind of bind together, or they're granulated until they're very tightly together. But when we mix API, we don't really want big chunks because it will affect content uniformity. So with this texture analyzer, we can test how much force is needed to break them apart, and whether if we just add the API or any substance into the roller compactor, and because in the roller compactor it will still sort of blend it out, there will still be mixing and force going on, whether that force is sufficient to break up all these all these API that are sort of stuck or sort of merged together, or actually it's not enough and we need to physically break them apart, or at least sieve them before we put them into the roller compactor. And another machine we use is an inverse gas chromatography. So it is used to measure the surface energy of particles, or the wettability. And another similar machine used is Cruise DSA 100, which is a goniometer. So basically I think at the start people realized that different batches of samples can have different wettability, and how they define wettability or how they measure wettability was when you have a drip of water drop on the surface, they measure the surface area that's exposed, so they go under like a microscope kind of thing, like a camera, to take a picture. But with this inverse gas chromatography, they can actually measure the surface energy of the particle, so how strongly they adhere to each other or adhere to water molecules, and hence measure its wettability. So sometimes even similar API, different batches can have different wettability. They don't often do this like test, not on every sample, because it is very time consuming, but when needed, like when all other factors does not seem to be affecting the two batches, does not show any differences between two batches, but their properties are still very different, that's when they might test out this wettability test. And then we also have real meters, which is basically like the Schultz and FT4 that is used to measure the shear strength of powder, but this is for liquids, obviously, on the viscosity. And then there's another one which is PIC, so it's actually spelled QIC. It is a particle size analyzer. So what it does is it's a very fast camera sort of thing. So you have powder or particles that they'll vibrate, and then it will fall through sort of a cylinder, a loop, and then when it falls through cylinder, the camera will keep taking photos, and after that they'll feed into the computer system, and there they will analyze out the size of the particles, and then they will give you a graph. So under this particle size, what's the density distribution, things like that. Yeah. And another particle size analyzer is laser diffraction. So again, you take photos. So for the kick normally they prefer non-cohesive, so powders that won't get stuck together because they won't be separated and they'll just distort your results. Another one to measure particle size is the scanning electron microscope. So again, this takes a very detailed pictures of particles. It's actually quite similar to those photos that you see on viruses, bacteria, in textbooks. So they'll take the pictures and you can really see like how the surface of the particle is like. It's not all smooth, it's actually quite a bit rough, and then depending, because some particles they coat it with an extra polymer, we can use these microscopes to observe like how the polymers dissolve. So I don't know if you've learned this, but some of them is like they dissolve just by dissolving, some is because of osmotic pressure that so the outside surface is not soluble, but because the inside is, and the outside membrane or the polymer is permeable to water, so water enters into sort of the particle, and then when the osmotic pressure causes the surface of the polymer surface to burst open. So that's how they are able to actually visualize and see, oh, that is how the polymer causes the particle to dissolve. So yeah, it's not just like textbook reading, they actually have to find out tests about it. And we also have a Malvern. Sorry, this is going to take a bit long. So it is a GMP machine that's used to determine particle size. So this is something that they will definitely need to run through to get the data that is recognized by GMP. And then we also have the differential scanning colorimetry. So I've talked about this before. It's for thermal analysis. So it will melt the material and then it will let it cool and crystallize or turn back into solid and then remelt it. So just to see how heat will affect the material. We also have X-ray diffractors, which is again very standard like analysis method, similar to like NMR, just to measure the amount of material the proportion of different substances in a batch, for example. So yeah, I think finally I got like a more in-depth learning of all these different machines, how they do, and actually record it down. So one thing is to share with you, and the other thing is so that I can refresh my memory next time. But I found the tour really useful, and to actually see what scientists have been like using in the lab and how they actually work. I feel like it's really cool. So I really enjoyed the lab tour, and I hope that based on my descriptions, I tried to attach some videos, but if not, you can always search out online on the machines and how they're used. I think that it is very interesting to check them out and actually visualize like everything that we've learned on textbooks into real life scenarios, and people actually do all these tests. It's not just like, oh, I think it's this because of this, but they actually tested it out. So yeah, something worth noting. And I think that's about. Oh, actually, today there's an AstraZeneca fest on campus. So actually, I have a short video where we played golf. We played mini golf with all the interns. So that was quite fun. So sometimes they have all these. I think it was for charities, for a fundraising program, but we had fun playing. So yeah, that is day 8, and I'll see you tomorrow in day 9. Which is actually really interesting because I will actually be heading into the lab to analyze my material finally. So yeah, I've never used that equipment before, and I'm going to get training on it. So hopefully I have more information to share with you as well. See you tomorrow. Bye. Hello, this is day 9 of me working in AstraZeneca. So today I actually went into the lab and conducted my analysis my first analysis in the lab. So basically what I used was the spectrometer, and what I had to do was to weigh out all my samples, not really weigh, but to measure them and put them into small bags, because we had to fill them into tiny bags like this big. I had to first fill them into tiny vials again and then pour them into the bags, and then we also had to create labels. We literally spent an hour going around different labs to find a small label machine that is functioning, and I think we don't really know how to use it. So that's a problem that we need to address, because right now we're cutting up from bigger labels, but now it's only like 20 samples, and later on we'll have probably 160 samples to test out, so it would not be practical to just cut things out. So we still need to figure that one out. But yeah, spending 1 hour walking around labs was very boring. But the weighing up part was really nice. I really liked the calmness of just being in the lab and just weighing things out. Not really weighing, sorry, just repacking them. And then yeah, and then we just put them into the machine. And so we had an analytical scientist showed me how to use the machine, and I feel like it was really cool, because so the theory, although they use a laser, is very similar to infrared, so you actually see the peaks, but because it's like a laser, it's like a camera, so depending on the color of your material, it might affect the data, the spectrum that comes out. So basically our API is quite fluorescent, so we had to lower down the exposure. It's almost like a camera. When it's too bright, you have to lower down the exposure so that we get a nicer curve, like there's no straight line where it just where it's saturated, and you don't get to see the peaks. And yeah, and then for each set we do it, we let it take a photo for 1,200 times. I can't remember, I think that was called accumulation. So basically they take the photos again and then they stack up all these readings, the scope, and then they give sort of like an average that you can physically see, or they give, not to say an average, it gives like a more clearer picture. It's almost like if you take the same photo 100 times and then you stack all those photos up together, the resolution will be better. Yes, the resolution will be better. So that's what we set it to do. And tomorrow we are going to analyze all our findings, so see if there's any variability between the different APIs and the excipients, because we're using different batches. Another thing about when I'm talking about variability is that it's really, not to say funny, but normally when we're in school we were taught to put everything in order, so that we don't mess things up, etc. But actually in the lab, to prevent these so-called human errors, or not human errors, but more like the machine errors, is like maybe some parts might get a different variability. Just in case that happens, they actually randomize the order of how we put the samples down. That's why it's so important to label each one of them. But yeah, that's what we did. So I think I kind of learned a new thing today, which is that you randomize samples to get a more accurate result. So yeah, that's mainly it for day 9, so today, and I'll see you tomorrow. Bye bye. Hello and welcome to day 10. It's Friday. This week has felt like such a long week because I really don't have much to do. I have read through all the background reading material that was given me today. So yeah, and this morning we actually have had a meeting with the whole team. So in that meeting, I really found out about like how important meetings are, because well, although it seemed like there was much to discuss about, but whilst one person may have an idea, they still need to check the feasibility with others, because other people, it's the specialty of others. So for example, for my project, we need to do some spectroscopy analysis, and so the team working on spectroscopy was deciding how many samples that we need, how many batches, how many different formulations we need to come up with to get an accurate visualization of the the differences or what could have gone wrong. But at the same time, they need to ask the formulation scientist, which is my supervisor, whether it's a practical amount of samples to prepare. And so they need to take the date and the time we have available into consideration. And at the same time, we also have a chromatography team, so working on the HPLC, and because HPLC clearly takes a bit longer and is destructive, so it takes longer, it takes more material, so there should be so they're looking to see how they can reduce the number of samples being used in HPLC. So I feel like a lot of these things, we have a lot of cost, time, materials to take into consideration. So luckily, material isn't that big of a problem because we had a lot in store. So we are able to make like bigger batches as well. Also, we need to think about accuracy. So if you prepare one sample and you only weigh the amount for that sample, it's very low. Imagine like one capsule is like 100 milligram, so it will lead to a lot of inaccuracy. We need to make larger batches, and when you make larger batches, you need to think about whether you have the materials to do so or not. And yeah, on my part, mainly I have to think about the logistics of what's the most efficient way to weigh out all the materials to make each blend, and then to make them into capsules. But I don't think that's a big problem for me because I've done this weighing before. What I plan is to do it by the excipients, by the API batch, so by the ingredients instead of by the formulation set for each blend. So yeah, that's mainly what happened in the discussion. And another thing, we also need to cross-check with the previous manufacturing methods, and this is something that I would have missed out if they didn't mention, which is like the order at which we add the excipients or the API. So we don't want the API or the excipients or some excipients to get stuck in the container of the blending of whatever container we use to add them to the blend. So there might be some excipients that we need to check, and I actually looked through the method control when I from the past data, and they added lactose first, I think, and then only the API, and then other excipients to help with the flow as well. Yeah. And then like how many rotations, I've written them down here, but I don't know if it will be similar for our case. So that's it. And then after that, we need to check the content uniformity as well. And previously they also did sort of like a root cause investigation on why there might be the non-uniformity in the dosing units. So I also took a copy, I printed them out on like what they have suspected and whether is it a likelihood source of error or it's less likely. So actually, yeah, we follow a lot of procedure, like not to say procedure, but we follow a lot of very logical ways to determine what could be an error instead of opinions. So that's something important to take note of. But yeah, that's the final day of the week. I can't wait to go home. And then yeah, basically go home, rest for the weekend, and we have some interesting activities this weekend. Hopefully the weather is good, and hopefully I'll get some good shots, and I'll see you in the next video. Bye. And also thank you for watching Ming Daily. Thank you for watching this series. And if you have any questions, drop them down in the comments below. If you've liked it, hit the thumbs up. And if you would like to see more of these contents, please subscribe to my channel so you get the most recent updates. See you next week. Bye. Also, a mini good news, I passed all my exams. Can't believe it, I was so worried about OSCEs, and I actually just passed it. I only got 50%, so I just got 3 stations passed. Oh, it was so crazy. But yeah, I'm so happy.